Hello, I'm New Civil Engineers news editor Rob Horgan, and joining me for a fireside chat is Atkins Senior Tunnel Ventilation Engineer Christian Perez. Christian has over 18 years' experience from structural and mechanical designs through to tunnel ventilation designs and tunnel safety assessments, which he has specialised in, becoming an expert in life and fire safety. Christian is Atkins project manager and technical lead on a variety of major international and national infrastructure projects, including Heathrow expansion, Blackwall and Rotherhithe tunnels refurbishment, Saltash and Hatfield tunnels, and Nashville Airport. So, without further ado, Christian, thank you for joining us today. How are you?
Thank you very much, Rob. Thank you very much. Yeah, I'm very fine, and thank you for the introduction. My mom will be very proud.
Good to hear. Good to hear. So today we're going to talk about a new way of performing hot smoke demonstrations. Before we get into it, could you explain where hot smoke demonstrations fit into the tunneling industry?
Sure, Rob. So, yes, hot smoke demonstrations have a very important role for tunnel operators and emergency services to understand and improve, the tunnel operation safety level in case of fire. So, this is really where we fit in the tunnel operation safety phase, right? However, I would like to add that these hot smoke demonstrations are not used often, as I need it, at least in UK. And the reason of that is mainly because of some practical limitations of the current approaches, right? So I think I am very happy to have the opportunity to talk here about this new technology, this new approach that we have been developing based on, during consultation with different tunnel operators, during my 15 years of experience, my role in the as a UK representative in PIARC and event like that. So yeah.
Yeah. Why are hot smoke demonstrations important?
Yes. I mean, if a hot smoke demonstration is defined and implemented correctly, it has been proven to have a great value to verify and improve, the operation safety levels, and that means because they support in the understanding of, for example, the response of different systems like the fire and smoke detection system, the impact of the ventilation system, and other mitigation systems like could be triple F suppression system on the smoke control, the evacuation process, and even the coordination of all agents that normally participate in this kind of events, right? So as you can imagine, just having in mind all these kind of points and actions to coordinate these emergency situations is very complex, right? And if you don't do it correctly, you can have dramatic results, right? Let's say that, So hot smoke demonstration. I think the reason why why that is because they help you to understand the interaction, all these systems, the actions you're going to take in case of emergency, detect weak points, and also improve them. As well, you can use them as a training for tunnel operators and fire services that they are going to face this event. And this knowledge is kind of very important in such a way. Fire drills and live exercise are mandatory in tunnels.
Very interesting. So you mentioned that before that there are some limitations on the current systems. What are they, and why is a new way required?
Yes, I mean it's true that that currently there are different approaches to generate smoke in tunnel, right? We have coal smoke, we have pool fires, we have even the possibility to burn a vehicle, right? So, as I have told you before, but some of them have some kind of limitations. If what you really want is to challenge your tunnel under realistic fire scenarios, right? So, for example, I mean, coal smoke doesn't really behave as in any way, as the smoke that is generated in a fire. It has not buoyancy, and for example, tunnel ventilation, the ventilation system of the tunnel is designed for facing that buoyancy. The other systems, for example, are considered risky. They have unconfined flame in the tunnel. They release dirty and toxic smoke. They require massive protection in the tunnel unless you decrease really the heat release. At that point, there is not any more as realistic as you want. And they also need longer closure times for the preparation and the execution. So for all that, this is why we need this new approach. Okay.
Yeah, understood. So what is it that Atkins is offering then?
Yes, yes. So what Atkins is bringing to the market is an advanced system, right, that is able to reproduce similar effects in terms of temperature and smoke flow as a vehicle fire, but in a safer and in a very controlled way. So I think that now the tunnel operator have the opportunity to assess the response of their safety measures and their realistic fire scenarios, but also have the opportunity for them, for their team, for the firefighters to really experience, the feeling of being in a realistic fire and get familiar and get confidence really with the emergency strategies. Before I have mentioned that, yes, I mean, we have developed this machine based on consultations and trying to get the minimum requirements to really have a system that can be useful and can be accepted by the tunnel community, right? And here we can see three of them, which I consider the most important ones. One is that it's safe for occupants and infrastructure. So that means that we are using non-toxic smoke. There is not unconfined flame in the tunnel. I mean, you can see in the picture that we are just operating the machine just at less than 1 meter, and everything is okay, right? And we don't need really to protect really the tunnel because we can control really what we have, the performance of the machine, right? Another point that I think is very important is that with this technology we reduce the business disruption, right? We know that closing a tunnel is a nightmare, and our machine has been designed and it's just located in a trailer, so we can quickly transport in the tunnel and perform several demonstrations in a very short period of time, right? And it's a non-intrusive technology, so it's quite good and quite efficient for the tunnel operator. And another thing that is very important, and this is the last point I would like to highlight, is that the performance is adaptable to the client requirements. I have previously said that we can reproduce similar effects like in a vehicle fire, right? So we can reach 500 degrees outside in the outlet of the machine. But power without control is not really useless. So we can monitor and we can regulate in real time the output of the machines to achieve really the requirements of the clients.
Yeah, all sounds great, really. Could you give us an example of a project where this has been used already?
Yes, Rob. Yes, I have brought some photos and videos from a project we did this year with Highway England. It was a Shaltas tunnel. That I have to say that it has been the first tunnel in UK using this technology, and they are quite happy, to be honest. So yes, in the picture we can see different very interesting phenomena for life safety perspective. Like you can see back layering in the right pictures, as well as the smoke propagation along the ceiling, letting this kind of free smoke layer in the top left pictures, and also the destratification process for any reason it can be. Probably, I mean, it's better to have a look to the next video. In such a way you can have a better flavor of what we are talking about the performance, the quantity of smoke and stuff like that. So this demonstration has been done to investigate the evacuation process, taking into account a predefined emergency strategy and also the response of the smoke detector and all these related systems. So here, I mean, we have already put the machine in the middle of the tunnel. We try to reproduce about 5 megawatts cart. We reach temperature about 500 degrees at the outlet of the machine. So you can see the propagation of the smoke along the ceiling, mainly because of buoyancy and the grading of the tunnel. So to be honest, the smoke detection system detect the smoke quicker, but we delay, the evacuation process, and to let the smoke propagate further. And yes, in 3 minutes, evacuation is instructed, and you can see really what you are seeing now on screen. So this is really quite interesting for investigate these kind of scenarios.
So how often do you run tests like this, Christian?
We have started to promote this service not so long, but so far so good. We are performing 3 demonstration tests already in UK. We have very positive feedback, and we also have used these examples just to show to different people, tunnel operators forum. We have a lot of interest, and we are working on different proposals. Probably the last thing I would like to say is that and this is a very short presentation, so we have already prepared and have prepared a lot of more detailed information, data, and stuff like that. So if someone is interested, I mean, I will really recommend them to drop me an email, and I will just send that to them.
Brilliant. Thank you, Christian. There's a really interesting video there at the end as well, just to see it in action. Thanks to Christian at Atkins for sharing the work on new ways of performing hot smoke demonstrations. Up next, we have a project case study on the Humber Tunnel Feeder 9 gas pipeline from Christian Chu, who is Technical Director from Atkins Ground Engineering and Tunnelling Practice, and Luke Marriott, who is Atkins Ground Engineering and Tunnelling Practice and Project Manager of the Humber project.